Good evening, everyone. So this is a NCERT question 6.1. The question it is saying that give the location of the center of the mass of the sphere. So suppose this is your sphere. So we need to find a center of mass for the sphere. After that, we need to find the center of the mass for the cylinder, ring, and cube. So they have also given that each of a uniform mass density. It has uniform mass density, right? Uniform mass density. It means that mass is evenly distributed. So if a mass is evenly distributed, then its center of mass will be at the center of the sphere. So this is the center of mass. Center of mass. Now, secondly, we need to find a center of mass for the cylindrical. So, cylinder, it is the symmetrical object. It is a symmetrical object, right? So, it will be at the central axis only. So, let us consider this is the axis and this is the 50 midpoint. So, at midpoint on the cylinder on the central axis only, you will get a center of mass. Okay. So this is a center of mass for the cylinder. Now next is a center of mass for the ring. So this is a ring. Okay. So this is a ring. So you know that the ring has also center, but at this point, so this is the center of mass because it is also a symmetrical object. And here also, if you see the case of the cube, so cube, it is a cube. So it will be at the cube. It will be at the center. Okay, let us consider. So it will be at the center. So center of mass, it will be like this. Let us consider a cube like this. Let us consider a cube like this. So this is the cube. So the center of mass will be at this point, center of the cube only, because it is uniformly distributed. Okay. Now another part of this question is that does the center of the mass of the body necessarily lie inside the body? As we have seen that, for example, we have seen that the center of mass does not necessarily lie on the center of the body, inside the body. See, this center of mass lies outside the body, lies outside the body. Okay, so this is the second part answer. So I hope you have understood now. Now it is a question 6.2. In 6.2, the HCl molecules, the separation between the nuclei of the two atoms is about 1.27 angstrom. Find the approximate location of the center of mass of the molecules given that the chlorine atom is 3.5 times the mass of the hydrogen. So this is hydrogen and this is the chlorine. So can we draw can we draw the center of mass of the hydrogen? Let us consider this is the center of mass of the chlorine. So this is H and this is Cl. And it is, as we know, that the whole mass is concentrated at the nucleus only. Okay. Now, can we can join it. So when we join this, so the distance between this is how much? This is 1.27 angstrom. Okay. Now we need to find a distance of the center of the mass. So let us consider H as a reference point. So at this point x is equal to 0 and at this point x is equal to 1.27 angstrom. Now we need to find the center of mass which is at mid between at this point, or it may be at this point, but we don't know. It may be here. So we need the position of the center of mass. So we know that position of center of mass xm is equal to m1 x1 plus m2 x2 divided by m1 plus m2 plus m2. Okay. Now as per the question, they are telling that mass m1, let us consider hydrogen mass, that is the mass of the hydrogen is m. So the chlorine has a mass of the chlorine is 35.5 times the of the m. Now just we need to put the value. So mass m1 is m into x1. So x1 position, this is the position of x1. So x1 is equal to 0. So we have to multiply it by 0 into mass m2. M2 is here 35.5 into x2 is 1.27 angstrom. Okay, divided by mass m1. So m1 is m plus 35.5 m. So here we are getting 0 plus 35.5. It is m 35.5 m into 1.27 divided by 35.5 m plus m. So this is 36.5 m. So mm got cancelled out. So finally center of the mass we are going to take is 1.235 angstrom, but we have to take only two digit. After two digit, so we can round off. So our answer will be 1.2 angstrom. Okay, so the position of the center of mass which will lie will be toward the chlorine only, which is 1.2 angstrom from this side, because chlorine is very much heavier. So the most of the center of mass will always try to be in the side of the chlorine. Okay, so I hope you have understood this question. Now a child sits stationary at one end of the long trolley, moving uniformly with the speed of v on a smooth horizontal floor. So let us consider this is a trolley. This is the trolley, and it is moving with the velocity v or a speed v, and there is a child who is sitting at this point. Okay, and it is moving with the velocity v. If the child gets up and runs about on the trolley in any manner, what is the speed of the center of the mass? So let us consider now it is the center of mass. It may be anywhere, so it has a speed v only. Now the second case they are telling that if the trolley is moving with the same velocity, that is v, and a child just stand up and walk here, or walk or run with some other velocity. So what will happen to the center of the mass? So velocity of the center of mass. So we can see here, that m- earlier the girl plus trolley is a system. It is not a different system. Okay, it is a single system. So when it runs, then also it is a single system only. If it is a single system, so there will be no effect. Why no effect? Because there will be no effect. For example, if a girl is applying a force on the trolley, and in this direction, if a girl is applying a force on this direction, so the trolley will also apply a force on this direction. So net force will be 0. If net force will be 0, so there is a no change in the velocity. If no change in a velocity, okay, so definitely there will be a no effect on velocity of the center of mass. Velocity of the center of mass. I hope you have understood right now. Okay, it is a question they have given that that so that the area of triangle contained between the vectors a and b is one half of the magnitude of a and b. So let us consider there is a two vector. This is a vector a, and there is another vector which is known as b, vector. Okay, now we need to prove that, so that the area of the triangle contained between the vectors a and b. So let us consider the area under the formed by the triangle which contains A and B is, let us consider this is the area. We have to show that this area of triangle formed is equal to magnitude of A cross B. Okay, we need to prove this. Okay, now how we will able to prove this? Let us make this bit like this so that you will able to understand here. This is the area. We need to find area. Okay, now if there is an angle, if there is an angle between A vector and B vector as theta, so can you tell me A cross B is equal to magnitude of A into magnitude of B into sine theta, that is AB sine theta. Now if we talk about this height, let us consider this is the height. So this height has a h is equal to how much? So if this is a theta, so as per the vector rules we can know that this is your b sine theta. So can we put here, like in place of b sine theta, a into h, we can put here a into h. Okay, so we can put here a into h, right? Now we need to find area of the triangle. So what is the area of the triangle formed by these two vector? Area of triangle formed by vector a and b. Vector a and b is equal to half into base is area into height h. So what is the value of h? Half into base into height. Okay, now now from these two equation 1 and 2, we can assure that the cross product a cross b is equal to half of the one half of the magnitude of a cross b. See here, we can a cross b is equal to one half of the area of the triangle formed by the vector a and b is equal to 1 by half of the a cross b only. So from this 1 and 2, we can directly write that the area of triangle is equal to half into a cross b. Okay, this we need to prove because a into h is the a cross b. So finally we have proved this. Okay, I hope you have understood this. Now the question they are asking that so that the a dot b cross c is equal to the magnitude of the volume of a parallelopiped formed on the three vectors. So first of all, you need to understand what is paralleloplate. Let us consider let us consider there is a parallelogram like this. This is the parallelogram, right? When you create a volume like this, so this is known as this is known as a this, see, let us consider this is a parallelogram. Okay, this is a parallelogram. So you know that this is a parallelogram, right? Now what happens? It is like this is a square. Let us consider this is a square, but this is a volume. So volumetric form of the square, or when we increase in this way 3 dimensions, so square become cube. Same way in parallelogram, what happens? We have to create same way. Let us consider this is a third vector. Let us consider this is a vector b, this is a vector c, and this is a vector a. So due to this vector, if you if you add on, so what you will get, going to get, see here, we can we can make a paralleloplate like this. So we have to find the volume, right? As per the question, they are asking that so that A dot B cross C is equal to the magnitude of the volume. So how you will able to find the volume? So the volume of volume of PRA pipped is equal to area of the parallelogram formed by B cross C. Area of parallelogram, that is equal to B cross C. Of area into height. Okay, we don't know about the height. So we should consider there is a height like this. Okay, height of the parallelogram. I can also make one more diagram so that you will get clear here. So this is a parallelogram. There is a height h like this. So this is a C, this is a B, and this is the height of the parallelogram, and there is a third vector A. So this is the third vector A. We need to find the volume, right? So let us do like this. Okay, we have to make like this. See here, you can now understood that how to find the volume. So before volume, you have to find the area. So area of the parallelogram is equal to B cross C, okay, into height, right? Into height. This is a multiply. This is a B cross C and into multiply into height. Okay. So how to find a height? So let us consider, if I will shift this height here, so this is the height. So what is the angle between these two, height and area vector? So let us consider a theta. So this height is equal to A. This is the vector A. So height is equal to A cos theta. So in place of height, we can directly write here, in place of theta, B cross C into A cos theta. Okay, so can we see here that it is B cross C magnitude into magnitude of A into cos theta? So can we write here A dot magnitude of A dot B cross C? So this we need to prove. Okay, so finally we have to prove this. Okay, so this is the magnitude. Why I have taken magnitude? Because so that volume should be always positive. That's why we have to prove this. So I hope you have understood now. Now this is a question number 6.6. So let us read so that you will able to understand. Find the component along xyz axis of the angular momentum L of the particle whose position vector r of the component xyz and momentum p with the component px, py, pz is given, so that if the particle moves only in xy plane, then the angular momentum has only z component. Let us consider first part only. So first part, they have given the position vector. Let us consider the r is the vector whose position vector they have given. So this is x I cap plus y j cap plus z k cap. Okay, and we have also given momentum in I direction. So this is, they have given px I cap plus py j cap plus pz k cap. Okay, so these are the thing. Now we need to find linear momentum, angular momentum. So what is the formula for the angular momentum? Angular momentum is equal to angular momentum is equal to L, which is equal to R cross P. So we have to do the cross product only. So how to do this cross product? So it is three dimensions. So if you want to do R cross P, so this can be written as I J K. In place of R, we have to write X, Y, Z, in place of P, we have to write third component Px, Py, Pz. And now we need to find the cross product. So this cross product will be equal to, if I will take I as a common, so this we have to multiply this y into Pz minus z into Py. Now we have to take minus j cap, you know the rules. So this will be x p z minus z px plus k component, that is equal to k. For k component you have to take this leave, we have to take this. So this will be x py minus y px. Okay, so this is the final product. Okay, now so that if the particle moves only in xy plane, so z component will be 0. If a particle moves in xy plane, so z component will be 0. Z component will be 0. So if z component will be 0, so what we will get now? So if z component will be 0, so this will be 0, this will be 0, this will be 0, so this will be 0. So only the component which left with us is x py minus y px into k vector. So if there is an x and y plane, if there is an x and this is y plane, so the object will do the angular momentum in the direction of z, that is upward direction. Okay, so I hope you have understood this. Thank, thank you for. In this question, they have given that two particles, each of a mass m and speed v, travels in opposite direction along a parallel lines. So let us consider this is our parallel lines, and this is a parallel lines. Okay, this is the parallel lines, and there is a two particle. Let us consider this is the particle 1, which is moving with the velocity v and having a mass m, and there is another particle which is moving with the velocity v having a mass m. Okay, travel in a opposite direction along the parallel lines separated by a distance d. So let this distance be is how much? This distance is d. Okay, this distance is d. So that the angular momentum vector of the two particle system in the is the same whatever be the point. So let us consider this may be the point anywhere you can take. This may be the point P. If you increase the distance, so angular momentum L is equal to mass into velocity into radial distance, that is perpendicular distance from the point about which I am taking the rotation. Okay, so R is perpendicular distance only, right? Perpendicular distance. Okay, now as per this question we need to prove that the total, so that the angular momentum vector of the two particle system is same whatever be the point about which the angular momentum is taken. See, for if you consider a single particle system, so what will happen if you increase the distance, so angular momentum will increase. But here we are taking a two particle system having a velocity v and mass m. So let us consider now. Let us do separate. You have to find a separate angular momentum. So if I want to find a angular momentum La, this is equal to mass into velocity into what is the distance between this 2 points. Let us consider this distance is how much h. So this can be written as d plus h, right? Now, if we consider angular momentum for a body B or a B, so what will be there? So mass into velocity into the perpendicular distance. No matter what is this distance, we have to take the line of action of the velocity and the point from which we are considering should be a perpendicular distance only. So the perpendicular distance is h. But one thing you should notice that this object tries to move in this direction, but this direction try to move in this direction. So it means that both are in opposite direction. So the angular momentum will be in opposite direction. So total angular momentum is equal to LA plus LB. So by using this, MVD plus MDH, MVH, MVH minus MVH. So this MVH got cancelled. So MVD. So see here, as we have seen that both the particle have a mass m, velocity v, both are traveling with the velocity v, and they are separated by distance d. So distance d will remain constant. It will remain constant. So finally total thing will remain constant. Hence total angular momentum vector angular momentum vector of the two particle system two particle system is same or remain constant. Okay,